back and cover some of the quadratic function because it's probably the most important part that you can do. And always do the basics in these things. Just making sure the microphone works. Yeah, always do the basic steps in these things because it's good practice, and they usually do it because they're skill sets you need to refresh, right? So here you will notice we're no longer doing y is equal. It's no longer y is equal to x something with x. It's replaced by f of something or f at something. So when you see f of 1, let's take that one. F of 1 is essentially the same as saying what is y when x is 1. So you're taking this f of 1 and you're putting it into this formula. So 1 squared, 1 times minus 3 plus 4 minus 1. So f of 1 is equal to 0. We would write it like this. F of 1 is equal to 0. And all it means is when 1 is put into this equation, we get 0. And it's the same as what is y when x is 1. And if you were to graph on an xy chart, you indeed use that interpretation. 0x, sorry, we got 1x right here is 0y. So it's right on the x-axis. So it helps to just understand the process and review it. So this just means I'm putting minus 2 into the equation. So same thing. Minus 2 squared is 4 times minus 3, minus 12, minus 8, so minus 20, minus 1, minus 21. So you put that as equal to minus 21. Same with this one. You put the third in, you squared it, you get a ninth, times minus 3, you get minus a third, plus 4 over 3. So now you're talking about 1, and minus 1 is 0. So interesting enough, 1 of 3 gives a 0 as well. So remember we had 1 of 1 is 0, and now we have 1 of a third is 0 as well. So since this is a quadratic equation of parabola facing downwards, those are the x-intercepts, and the vertex will be somewhere up above. Then they want you to realize that when you do f of 0, you're essentially always going to come up with this last number here when it's in standard form. And sure enough, that makes that 0, and that makes that 0. And this gives you the y-intercept. So minus 1. So it's interesting to note that the y-intercept is always the number in a standard form quadratic equation. So when you are asked f of 0, you can just look there. And then this is just to show that you can plug anything in and not solve it. So the only thing we can come out with this is it's minus k, 3k squared, plus 4k, minus 1. And that's as far as you can take it until they tell you what k is worth. But for now, it's just to show that these things are so flexible, you can put anything in there. And they want you to get into the habit of putting other equations in. Now, this minus k, it's interesting to note, you should put it in wherever you see x, so this minus k gets squared, and still becomes minus 3k squared. The same as this one. However, where it changes is right here. Plus 4 times minus k becomes minus 4k, minus 1. So we can see that this produced this difference compared to that. And it's also to get you to used to flexibility of these equations. And that's why we move away from y is equal to x, because f of x functions are far more flexible. Then they want you to get used to expanding. And that's a very important skill. So that one goes x squared minus 3x plus 5x minus 15. And this right here becomes plus 2x. So you get to just used to adding up the two middle terms. And that's the expansion of that. And it's to show how to go from factored form to standard form. And that you are eventually supposed to learn how to go backwards. And then this one, it's distribution. So you get 2x squared plus 12x. And this one is vertex format. So you have to distribute this first. Then you apply the minus 3 to it all. So you get minus 3x squared minus 12x minus 12. Once you distribute that, and then minus 3. This just simply means this times itself. That's what the squared means. So you do x plus 2 times x plus 2. And then when you multiply all that by minus 3, that's what you get. There's a minus 12 here. And then remember to add the plus 3 to the minus 12. So the minus 12 actually becomes minus 9. And there's the distribution of that. And it's to show how you can go from the vertex form to the standard form and how you'll need to learn how to go backwards. You go backwards by something called completing the square. And we'll get to that later. And then this is the same thing. It's just x minus 1 times itself. Now I also want you to get used to the notion of when it is something times itself. This is the pattern. So it's always going to be a squared, the first term, plus or minus, well, let's just say plus 2ab, plus b squared, the last term. So right away, I can just say, well, it's going to be 2 times this term, which is minus 1, times that term. So it's going to be x squared minus 2x, and then the minus 1 squared is always plus 1. This expansion is always the rule for a perfect square like that. And it's something to learn. Now here they just want you to get used to graphing. State the axis of symmetry. The axis of symmetry is always going to be the same as the x value of the vertex. So right here, here's the vertex, and we can see that it's minus 3 comma minus 4. That's the vertex, a coordinate. The axis of symmetry is x is equal to minus 3. It's always this value here. And it's a dotted line that goes straight up and down. It cuts the parabola exactly in half. That's why it's called symmetry. Okay, so I'm just going to continue. We're going to take the rest of the page here. As much as we can. And what about this vertex? Oh, domain and range. So domain of parabolas is always the full thing, XER, unless you're working with a real model like time or basketball or something that hits the ground. But for just general parabolas, XER is always the domain. The range is always limited by the vertex. And if it's a minimum vertex, the range is always above the y value of the vertex. And if it's facing down, it's always y is smaller or equal to the y value of the vertex. So the range of this one is y is smaller or equal to minus 4, because we get it right there. And that's true. Any y value in this graph will be minus 4 or smaller. And this, we can see the vertex is right there, 5 comma 1. So here's the axis of symmetry. Lines are always x is equal to something or y is equal to something. These are vertical lines, and that would be a horizontal line wherever y is 5, right here. And so that's its axis of symmetry. X is equal to 1, which is the same as, sorry, I got that wrong. X is equal to 5, which is the same as the x value right there. Then its domain is XER, and its range is y is bigger or equal to positive 1, because that's its y value and higher. State the vertex, axis of symmetry, direction of opening. So if it's in vertex format, you're going to see it quite easily. So for this one, it's not easy to see unless you solve it. However, it is technically in vertex format right now, and the vertex is 0, 4, which means the axis of symmetry is x is equal to 0. Now, how do I know it went through 0? 0 is because there's no extra number here to confuse things. There's no plus, that's not plus 4x plus 4. That's just plus 4, which means we have a perfect square there, which means x is 0. And then 4, so the whole graph is raised by 4. So that's its vertex. Its axis of symmetry is x is equal to 0, the same as that. And its direction of opening, because it's a positive number in front, it opens upwards. So what about this one? Well, that's in vertex format. So for vertex format, you get the x value by making the opposite sign of that x, and the y is exactly as seen. So there's the vertex. Its axis of symmetry is going to be the same as the x value for the vertex. And then its direction of opening is upwards because it's a positive 3 in front. Okay. Again, opposite x value here. This is vertex format, minus 7, and the y is exactly as you see it, minus 3. So that's the vertex, which means the axis of symmetry is x is equal to minus 7. And it also means that the direction of opening right here, that's a negative, so it faces down. And then finally, if you look here, you can see that this negative says it's facing down. and this is factored format. So the only thing you can learn from factored format is that it's going to go through the opposite x value of here. So it's going to go through -2, and it's going to go through +5. However, the axis of symmetry will be exactly between these two numbers. Whenever you want to find something exactly between two numbers, add them together and divide by 2. So 5 plus -2 is 5 minus 2. It's 3 divided by 2. So that's the same as 1.5. So that means the axis of symmetry is that x is equal to 1.5. Or you could have put 3 over 2. Now if I put that into the equation, I'm going to get my y value of my vertex. So that's the x value. So I know that the axis of symmetry is x is equal to 1.5. If I put 1.5 in here, I get 3.5 times negative 3.5 times negative 3. So this negative is going to make that negative and then positive. So we're dealing with a positive number. 3 times 3.5 is 10.5 times 3.5. Oh boy, I'd have to, I can normally do it in my head, but today's a rough day. Let's make sure that 3 times 3.5 is 10.5 too. And then, yeah, then times 3.5. 36.75. So we can see that we're dealing with a vertex of 1.5 comma 36.75. And yes, you might have to express that in fractions. And then which way is it opening? Well, that's a minus number, so way up top at that vertex, the whole thing is facing down. All right, so this is about factoring. So whenever you factor, when there's no number in front of the x, it's quite a lot easier. So you say, what number multiplies out to 24 and adds up to -11? Well, because this is positive, I know I'm dealing with two negative numbers, and I can see -11, so it's going to be something like, it's got to be 8 and 3, because the factors of 24 are 24 and 1, 12 and 2, 6 and 4, 8 and 3. And as you make them all negative and you add them together, there's only one that adds up to -11, and that's this one, -3 and -8. Now, to write that as a factored format, you do x minus 3, x minus 8. And if uncertain, what you do is you expand it to see if you get back to where you started. So sure enough, x squared minus 8x minus 3x makes -11x, and -3 times -8 makes +24. So that's how you do that. And you do them all like that when there's no value of x in front. And you also want to see if you can factor out the number in front of x as well. In this case, we're looking for a number that multiplies out to 3 and adds up to -6. So right away, we're dealing with an impossible value. -1, -3 is the only thing that works. So you'd have to use something that's called the quadratic equation in here. Now, you can go ahead and look up the quadratic equation, but there's also quadratic equation solvers. But if you're not used to the quadratic equation, you shouldn't use these tools. I use them because I don't want to do it over again. But right here, down here, you can see the quadratic equation. And you're always going to come up with two possible values. You can come up with 0, 1, or 2 possible values. So in this case, we know that the x values, the number in front, so you follow this rule. So you're taking the number in front of x squared, the number in front of this x, and then that last number, and you're putting it into this equation. And then we're dealing with 6, and I believe it was 3. Let's see, -6. So we've got to change that. And then you click calculate. And sometimes there's no answer. Now in this case, it's 3 plus or minus the square root of 6. And in decimal formats, they give it right there. So you can see when you can't factor, you have to get comfortable with using the quadratic equation, which I didn't really demonstrate, but I think I demonstrated what you have to do. And this is written as a radical form, which is the most accurate, and that's written as decimal form. Two possible answers. So if I were to draw this, I know immediately, when you get these, they're called roots. They're the opposite of the factors. So I know it goes through 5.5 0.44949 and 0.5555. I know it's facing upwards, so the vertex is going to be somewhere down here and goes up. And then finally this one is, oh actually no, let's go to this one here. This one's here is tricky because you've got to consider the 3 in front. And now you're not looking for a number that multiplies out to -5. You're looking for a number that multiplies out to, what's plus 3 times -5? -15, and adds up to -2. Now there's only a few factors of 15, 15 and 1, and 5 and 3. That's the only one that could possibly add up to -2, and I know they're plus and minus because this is a minus, so we're talking with -5 and +3. Now, the problem, so -5 and +3. -5 +3. Now the problem is, you can't just put x -5 and x +3. You have to do several methods. You have to take this -2x and break it into its two components of so you can see that these add up to -2x. Then you throw in their numbers. And then I can see, called by grouping, in the first two I can take out 3x. I'm left with x plus 1. And in the second group I can take out -5, and I'm left with x plus 1. And when I have these two things as multipliers for these two things, I now know I can factor out that from both of them. So I factor out x plus 1, and I'm left with 3x minus 5. So that's one method. And you can always test it out and multiply it out and get back to here. The other method that I actually like, knowing that I'm looking for -5 and +3, is called the slip and slide method. It's a little bit faster. So you just put x -5, x +3, and you take this number and you bring it down. And you divide each of these numbers by that number. So over here, when it can divide, see over here, it can divide, you just replace it by what it divides by. And it divides by 3 by 3, 1. Over here, I can't divide -5 by +3, and so I simplified as much as I can. I have. So here's the slide part. That 3 slides in front of the x. And suddenly we've learned the same factors that we learned before, called the slip and slide method. And there we go. I've got the same factors a little bit faster, but you got to get a bit comfortable with it. Okay. Now I believe this last one I accidentally deleted it. I don't mean to spend so much time on this section, but it's always good to refresh your skills. Always. Okay. Do that. And so it's the last one. The secret is you want to get all the things to one side. So let's go all to this side. So I'm going to subtract -x² from both sides to get rid of it. What's 3x² minus 1x²? 2x². Then I'm going to subtract 9x from both sides to get rid of it. What's 2x minus 9x? Minus 7x. Then I'm just going to add 3 to both sides to get rid of it. And I'm left with this. So now I have an x, a number in front of an x. So now I'm looking for something that multiplies out to +6 and adds up to -7. Well, there's only one factor of 6 that can do that. It creates a +6 and adds up to -7. That's -6 and -1. That multiplies out to +6 and adds up to -7. Now I'm going to do the slip and slide method because I like it. So I just do x minus 6, x minus 1, and I take this 2 in front and I divide them both by 2. 6 can be divided by 2. Becomes 3. 1 can't be divided by 2, and it's as simple as it gets. So that's when I slide this over and I bring the 2 up in front of it. And boom, I have my two factors. And you can always test it out. X times 2x, 2x², minus x minus 6x makes -7x, and then -3 times -1 makes +3. And boom, I found my two factors of that. And I just want you to revisit your skills. Very important. So this one, you have to spot right away it's a difference of two squares. And therefore we have found the factors, and when you find the factors, the opposite values of the x are the x-intercepts. That's the reason for this is when it crosses the x-intercept, y is 0. So y here would be 0. Either of these brackets, if they become 0, when they multiply out whatever the other thing is, creates a 0. So that means either of these brackets becomes a 0, it gets our result. Well, this bracket becomes 0 when x is minus 3, and this bracket becomes 0 when x is positive 3, which is why their intercepts are the opposite of what's there. But once you factor, you can easily find the x-intercepts. What about this one? Well, again, you have to see if it's factorable. There's nothing in front of the x, so it's a 1. And if it was minus here, you'd have to factor out the minus 1, by the way. But anyway, we're looking for something that multiplies up to negative 18 and adds up to minus 8. So we're dealing with a plus and a minus. So we're dealing with 6 and 3. Oh, there it is. No. No. We're dealing with 18 and 1. No. 6 and 3. No. Oh, look, it says answer to decimals, so some of these are going to be factorable. 9 and 2. Almost, but no. And those are the only factors. So right away I can see that none of them, plus or minus, adds up to minus 8. So I'd have to use the quadratics. I'd plug in 1, minus 8, and minus 18. And I get these two possible factors. Now, the interesting about the quadratic is you don't have to make them the opposite. It spits out the exact x-intercepts known as the roots. So that means my x-intercept for this one is 9.83095, comma 0, and it's positive there, so it's just positive, and negative 1.83095, comma 0, the exact thing here. And that's because the quadratic function actually finds x exactly for you. It doesn't make you do the reversal of like the factor. This is factored form. These are called roots, and the roots give you the exact x value of the y-intercept, of the x-intercept rather. All right, it's very similar, except we're dealing with a more complicated x squared. So when I multiply minus 3 times minus 8, I get plus 24, and it's got to add up to plus 10. So I'm dealing with a positive and a positive, and I can see that it's plus 6 and plus 4. Multiplied makes 24, adds plus 10. So I'm going to use the slip and slide method. And actually, technically, to be fair, that what I did was incorrect. I have to get this positive in front, so I have to factor out a minus 1. And incidentally, I get the same rule. It's something that adds up to there we go, positive 24 and minus 10. So it's important to note that you need your front leading x factors positive. So again, I'm not dealing with positive 6 and positive 4, I'm dealing with minus. So big distinction. Now I'm going to do my slip and slide. I'm going to leave lots of room. I'm just going to write down the exact factors as discovered. And then I'm going to take this front value and I'm going to divide both of them by the front value. I can see that x minus 6 will indeed make 2. 6 divided by 3 will indeed make x minus 2. And over here, when I divide by 3, it can't be done. So I just slide the 3 in front. And just to test it out, 3x squared, and remember there's a minus 1 still factored out over here. 3x squared, yeah, that's what I get there. Minus 6x, minus 4x, minus 10x, yeah. And then plus 8. So those are correct. which means my x-intercept values are 2, 0. That's for x has to be 2 here to make a 0 result. And over here it's tricky. You just set the 3x minus 4 to equal 0, and you get 3x is equal to 4, and you get x is equal to 4 over 3. So that means the other x factor is positive 4 over 3, 0, which could also be written as 1.3 repeated, 0. Either is correct. This is more accurate. So notice that this was a little more trickier to find the exact x value, but it still works. You set the whole thing equal to 0 to solve it. Sketching. Sketching's an important skill that they'll want to test you on over and over again. So right there, I can tell there's no 3x, so that's really vertex format in a tricky way. So that means I know it's facing up as well because it's positive. So I know it's 0, plus 3 is the vertex. 0, plus 3. There's no stretch in front of the x, so I just know it's a normal parabola. The only difference between this and the parent function is it's been raised by 3. Okay. This one looks tricky. And yeah, you cannot find the it the way it is there. You have to factor out the 2 first. Okay. And this time you'll notice there's no number here. All right. Now, for you to find the exact square there, you would need to complete the square of this, to be honest with you. Let me make sure of that. Actually no. So right there I can just factor out the 2 in front of the x squared and leave it minus 4 over here. And I believe I have it correctly. Yep. I think. Let's see, 2x squared minus 4. Yep. It's just factoring the 2 out of the front. You realize you have a stretched parabola. So right there, when I factor the 2 out in front, I realize, okay, it's going through, get rid of this old one. It's going through 0, minus 4, faces upwards, and this 2 makes it thinner, stretched. And I could get more details, like I could figure out the x-intercepts and get there. And you always get more detail. This one is interesting because they give it in factored form. So the x-intercepts, which are opposite here, you can just notice that makes it face down. That's the only impact. And the x-intercepts are 2, 0 and minus 8, 0. And right away, I can tell you that if I take the average of those, so 2 plus minus 8 and divide by 2, I get minus 6 divided by 2, which is minus 3. I can tell you the axis of symmetry is right here at x is minus 3. And I could find the y value of that by plugging in minus 3 into the formula. So I get minus 5 times 5. So that's minus 25 times plus minus 1, so it's plus 25. So up here at minus 3, plus 25 is the vertex, and it faces down and goes right through those x-intercepts. That's a pretty accurate drawing. So this one is just how you read the x vertex. So right there, it's the opposite, and exactly as is. And it's facing down. So you would draw your graph, and you'd start at minus 2, plus 3, right there, and you'd kind of go like that. And yeah, you could find the, when x is 0, this becomes minus 4 plus 3, which is minus 1. So it almost tells you right away that it actually comes down here and goes through 0, minus 1. So if you wanted a little bit more accuracy, you could quickly figure out the y-intercept. You could also expand it and factor it and find out the factored form, but really they just want a sketch, so you don't have to get hellishly accurate. And that's what they want you to cover. But if you're going to review one skill in 3.1 that we're coming up to, it's this. It's first difference, second difference, third difference, fourth difference, and it's incredibly important, and I'll review it again. But essentially, if you just have the data, and you first look at all your y values, well, first of all, make sure all your x values are separated by 1 to do this. If not, you have to do an extra step. But if they are all separated by 1, you can find what's the first difference. So what's the difference? How do you get from minus 32 to minus 14? You add 18. How do you get from minus 14 to 0? You add 14. How do you get to 0 to 10? You add 10. And so you can see here, these are the first differences. And notice it starts going the other way here. So right away you can see these numbers are not the same. If they were the same, we'd be dealing with a line. So you go to second differences, which is the differences between these numbers. Well, this 18 to 14, minus 4. 14 to 10, minus 4. 10 to 6, minus 4. And when you get them all the same like that, you're not dealing with a line now. You're dealing with the next term up, x squared. So now we know, because those are all the same, we're dealing with a parabola. If they were not all the same, you'd have to go to the third differences. And if the third differences were all the same, you'd be dealing with a cubic, x to the 3. If they were not all the same, you'd have to go to the fourth differences. And if the fourth differences were all the same, you'd be dealing with a quartic, x to the 4. And so on and so on and so on. Very useful. You can derive an entire formula just knowing the first, second differences. If you're just looking for a line, you just need 2 points of data. Well, 3. If you're looking for x squared, you need 4. If you're looking for x cubed, you need 5. If you're looking for x to the 4, you need 6. And so long as you have 2 more, I believe, than the power, you will be able to derive the entire formula from the data, so long as the x's go up consistently by 1. Even if the x's go up consistently by 3, you can figure it out, but you have to divide all the y differences by 3, because you're not really determining the first difference anymore. You're determining the difference every third step sort of thing. Anyway, important, really important skill to learn.